After learning the first assumption in the previous video, we will now cover the second assumption. The second assumption is there should be fixed x values or x values independent of error term u. We assume that x is fixed even if it is not fixed to make the model simple. A random variable x is generally considered non-stochastic even if it is stochastic. The reason for this assumption are first to simplify the analysis. Second, in experimental situations it may not be unrealistic for researchers to assume that x values are fixed. Third, even if the x values are stochastic, the statistical results of linear regression are valid under the condition that x and error term are independent. That is, the covariance of xi and ui is equal to 0. The reason why covariance of xi and ui being 0 can make the OLS work even if the x is random is, although x changes randomly across observations, its variation is independent of unobserved factors captured in error term. Therefore, the random movements in x does not systematically move together with the errors, so OLS can correctly isolate the true effect of x on y. In other words, randomness is x itself is not the problem. The problem arises when x contains information related to the error term which causes endogeneity and bias in the estimates. It is important to note that if the x variables are stochastic, the resulting model is called the new classical linear regression model (NLRM). We will learn the remaining assumptions in the upcoming videos, so follow for upcoming videos.